So we're going to move on from the slidey scale. We are going to learn another method of converting. And this next little bit, I'm going to talk mostly about the slidey scale. If it's not working for you, come talk to me or let me know in an email. I have other ways of doing it, but the process that I'm going to suggest kind of for this next section hinges on that slidey scale, kind of that roadmap. So we've already done length as a variable here, typically talking about one dimension with length. And so we've used our slidey scale for that if we wanted to convert on the metric system. If we're going to talk about not one dimension, but two-dimensional measurement, that would be area. And so, you might talk about how many square feet your apartment is or how much flooring you need. You might also purchase flooring in square meters. And these are all area. There's both a length and a width to this. So if you want to convert within the metric system, you have to convert both dimensions. And so what you're going to do with the slidey scale, you're going to count each space as 2. So you're going to count by 2 because there's 1 decimal place for the length and 1 decimal place for the width. And so in this one, on the slidey scale, and I don't have it up in front of me, if I'm moving from meters over to centimeters, that'd be counting 4 places that way. And so you can see here, we've got 4 zeros after the 1, moving it from where it was to 1, 2, 3, 4, to where you want it to be in centimeters squared. And so what you're doing with these is counting by 2 on the slidey scale. If that's not doing it for you, I'm just going to show you briefly here. This might not be the way that makes sense to you, but you can use a process of dimensional analysis. This might actually put some people off, in which case just ignore it. We know there's 1 meter with 100 centimeters, and we want to do that conversion not once, but twice because of this squared unit here. And so in this, then you can see you're canceling out and converting to centimeters squared. And you get the same answer. You're going to end up with 10,000 centimeters. And so again, what I just did in pink is not the slidey scale. It's the other way of doing it. But just to kind of let some people off the hook if they're hating the slidey scale thing and remember another way, that would be probably the way that you remember these. So I like the slidey scale. I think most students often like it, but not all. And so let me know how you're doing with it. The last ones here, there's 3 examples, and I'll just put the answers up on the page here. So you can use your resources and maybe the way you like to give your answers. You can always pause the video if you need more time. I'm just copying my answers as I do these because I have a hard time talking and thinking at the same time. And yeah, so those are all counting by 2 because they're squared measurements. If we're going to move on, and we will, to 3-dimensional measurements, what we're talking about here would be volume. And so we could talk about, 3 different parts. We could talk about length, width, and height. And so in these, you end up with cubic measurements. And so cubic linear measurements are often for solids. They might be meters cubed, centimeters cubed, decimeters cubed. And in these ones, what you're going to do, because there's 3 dimensions, you're going to count by 3 as you move on that slidey scale. And so if we move from meters to centimeters, you'd start where in meters on the slidey scale and count by 3/6 that way. And so counting by 3 accounts for the 3 dimensions that you're dealing with in your unit. And so then you can see here we've got 6 zeros after the 1. These ones down here are the same. I'm going to use the slidey scale and count by 3s as I do it. And I'll put the answers. Again, you can pause this if you want a minute longer. And hopefully I haven't gone the wrong way. Let me know if I ever make a mistake in these videos. And that would be those 2. Okay, there's another way of representing volume. And so those are typically for solids. If you wanted to measure a volume of, say, water or oil in a kitchen, typically you measure them in milliliters. The standard unit for liquid volume measure is the liter. You'll find that these are in your formula pages. In the lab, I have a box that's made out of plastic, and it is 10 centimeters by 10 centimeters by 10 centimeters. So that would be 1 decimeter cubed, right? 1 decimeter, 1 decimeter, 1 decimeter. I also have a huge graduated cylinder. It's all big and scary, made out of glass, and one day I'm going to break it. And if I fill one of these with water, it is equivalent to the volume of the other. So this is 1 liter. And really what you get from this demonstration is that 1 decimeter cubed is 1 liter. So these are what are on your formula pages, right? They are equivalent units. You can use them to do conversions, but in these units, they're exactly the same size, they're the same number. If I were to take one tiny little box that's 1 centimeter in all directions, that would equal 1 milliliter in liquid volume. And I don't have a demo for that in the lab, but they are also equivalent units. And like I said, they are on your formula pages. And so top of the next page, we have some of these to convert. So in these, really what I'm banking on is that 1 centimeter cubed is 1 milliliter and 1 decimeter cubed is 1 liter. So if I do these conversions, what I should recognize is that those are equivalent units. And so we're not changing the magnitude here. We can simply change the units because they're the same amount. So this one down here are mixed. Some of them you're using this concept. Some you're using your sliding scale and counting by 2s. Some you're using your sliding scale and counting by 3s. And so having them all kind of muddled up is a good test for you to kind of tease apart your understanding. So I'm going to go ahead and put the answers up on the page here. And you might want to pause it and take a minute to kind of check your understanding. And again, I tend to write them out in standard notation. If you are using something other than a slidey scale, you can represent them in scientific notation. Just to finish up this section of chapter 2, the last variable that we sometimes use in chemistry would be mass. And so the standard unit would be kilograms, but that's often impractical in chemistry. So we usually use grams, that base unit, for mass. And we'll get into talking about mass as we go through more of the course and the math component.